If you're wanting to learn how to memorise the quadratic formula, you've come to the right place. G'day, welcome to Crystal Clear Mathematics, where it is easier than you think. I'm your host, Graham Henderson. There are many ways to learn mathematical formulae, and I've created links to some quite good ones in the description below this video. The method I want to show to you here is slightly different. The reason I like it and the reason I adopted it and used it when I was in school is that I wanted every formula I learned to be linked to the mathematics I already knew. And the best way I knew to do that was to learn the derivation. And surprisingly, learning the derivation does not take long and it's not difficult, but it has tremendous benefits. So what I propose to do is to write up the general quadratic equation and to derive the formula from it. When I've finished doing that, I'll explain how to memorise it and learn it well. So let's get started. The quadratic equation is y equals ax squared plus bx plus c. These kinds of equations occur right throughout mathematics. You can find them cropping up in geometry, trigonometry, calculus, and the list would go on and on. So it is quite important to learn this skill, how to solve them and how to use them. Of course, in this form, if we graph them, we get a kind of curve known as a parabola. If you choose any particular x value and substitute it in the equation, you'll get a value for y, which will tell you some point on the parabola. You substitute another x value, you get another y value. Now, when graphing parabolas, one of the key bits of information we like to know, or one of the key points or pairs of points that we want to know, are the points where the parabola crosses the x-axis. We find these because the equation for the x-axis is y equals 0. Remember, it's the x value that changes along the the x-axis, which is why it's called the x-axis. But the y value is 0 because you've not gone up or down the y-axis at all. And if we set y equal to 0, so 0 equals this, or this equals 0, and solve it, we actually find these 2 points known as the roots. And that is what the quadratic equation is for. It's for solving not this equation, but this equation. So I'll conveniently get rid of the y equals. And we're going to start with this and derive the quadratic formula, which in essence is a rearrangement of this same equation. Now, the method we use for solving the quadratic equation is called completing the square. So in the very act or process of deriving the formula, you're actually practicing another skill that you need to understand. Now, to complete a square is a bit more difficult when you don't actually have numbers as a coefficient. So we've got to practice our algebraic skills quite a lot. We don't like, as a rule, to try to complete a square when the leading coefficient is not 1. So we want to remove this a by dividing everything by a. These, of course, divide out. We have one lot of x squared plus b over a, lots of x, plus c over a equals 0 divided by a is 0, conveniently. This is a big improvement, and that's your first step. Your second step is to remove this constant, because c and a are both constant terms. We need to remove that because to complete this square, we're going to put a different value there. So we subtract it from both sides of the equation and get, I'm going to write it over here. So we've moved it over there. We now need to find a value that will complete this square. And when the leading coefficient is 1, the rule's quite simple. We halve the coefficient of x, and the easy way to do that is just double the denominator. though we multiplied the fraction by a half, and square it. So it's actually b over 2a squared. That completes the square. So it's half of that by putting a 2 in and squaring it. Now, of course, we have an equation here, so we can't add this without adding it to the other side as well. Now the equation is still balanced. That step from here to here is completing the square. Now, because this square has been completed, it is a perfect square, and it is x plus b on 2a all squared. Now this side we can simplify a bit. We'd like to try and get this fraction and this fraction combined into the one big fraction. Let's expand this first because it is a square. So b squared over, and the square applies to the 2 and the a as well, so 2 squared is 4, and a squared is a squared, of course, minus c over a. And to combine these, we want the denominators the same. A already divides into 4a squared. It divides 4a times, that is a times 4a makes 4a squared. So that's exactly what we do. We multiply the top and the bottom of the fraction by 4a. So we have 4a squared here and 4a squared there, which means our resulting fraction will have 4a squared on the bottom. This part has a b squared on the top, minus, and this part has 4a times c, and you can see here part of the quadratic formula appearing. I'll just copy this again. Now we take the square root of both sides to get rid of the square. That gives us x plus b on 2a equals the square root of this. Now the square root of 4a squared is 2a, and the square root of this we just simply can't do, so we put a square root sign or a radical sign over it, b squared minus 4ac. Now we have a slight problem. Whenever you take the square root of both sides of an equation where pronumerals are involved, you should use absolute value signs, which means we have to allow for a positive or a negative result. To isolate x, we must remove this last term and take it over there. Fortunately, it's still over 2a, so we can take it out all over 2a. This plus b over the other side becomes a minus b, plus a minus square root b squared minus 4ac. And there is our quadratic formula. Practicing this derivation is an extraordinarily useful tool. How long does it take? Once you know what you're doing, it takes maybe 2 minutes, 3 minutes. If you do that once every afternoon, following this simple pattern, set time aside without distractions. That is, you must focus. If you focus, you're going to benefit from this. If you try and do it while you're watching TV or listening to music or something, it's far less likely that it will stick. So just for these 2 or 3 minutes, get rid of all distractions, concentrate, and derive the formula. That's it. When you get to the end, just check with your master sheet that you have in fact followed all the steps properly. You only have to do that once every afternoon for 2, 3, 4, 5, 6 afternoons, however long it takes, until one day you're doing it and you think, I have so got this, this is so simple. That means you don't have to do it anymore. So I'll just put here once per day. Now you can do it more often if you wish. The third principle, there are 4, the third principle to learn this well is at the same time of doing as you do this is to use the formula to solve equations. means get your textbook, find the exercise where you're given a whole lot of these quadratic equations to solve, and do a handful of them. Now, the more of these you do, more intensively, the better you're going to learn. This is what we call massed practice. And it's vital for good long-term recollection of the skill and the facts. And the last thing is to do what's called distributed practice. And that is to get your diary and to ask yourself 3 fundamental questions. Am I fast enough? Normally that's the second question I ask. The other question is, do I understand? These are the 2 questions you should be asking yourself all the time you're doing the maths practice. When you can tick them both and say, yes, I understand how to derive the formula, I understand how to use the formula, and I'm fast enough at doing both, then you ask the 3rd question, which is how long before I forget? Because forget we do. It is very simple to forget. And if you're honest with yourself, this is a very personal question. You might feel that you can go 6 months without forgetting. Some students will. You might decide it might only be 2 weeks. And somewhere in between there'll be a time when you think, yes, I think I'll understand it to here but not here. That's when you write a little note in your diary to revise this derivation and then to use the formula again and to ask yourself the 3 questions again. If you choose this date properly, the whole practice of this, the whole study of it might only take you 10 minutes. If you time it badly, you will have to relearn the derivation and possibly relearn the use of the formula. So it pays to be very honest with yourself and to err on the side of caution. So if you think you'll be right for about 2 months but you're not sure about 3 or 4, put a note in your diary in 2 months' time. I know I've repeated myself a little, it's part of the way I teach, but I hope this helps. Do the derivation, do the practice, make sure you do it without interruption, that you've actually set time aside to do it. Ask the questions and use your diary to make sure that you recall it at intervals of time right all the way up to your exams. Thank you for watching.